So welcome everybody to the May 27th, yeah that's right, 2015 edition of the professional VMware.com vBrownbag. Tonight we're continuing our VCP6 series. We're talking networking with Brian Welch. Just some quick show notes. You can join in on the conversation using the hashtag vBrownbag. Or you can use the GoToMeeting window to ask questions or leave comments. Snarky remarks are also welcomed as well. Remember that there are other podcasts going on globally, so check those out. And you can download the shows via iTunes or directly from professionalvmware.com. Tonight's guest is Brian Welch. You can find him on Twitter at Brian Welch. I'm your host, Ahmad Yunus, on Twitter at Ahmad_Yunus. And with that, I'm going to pass. It's all yours, man.
Thank you. Well, thanks for that, Ahmad.
Sure.
Just a couple of things before we get going here. My name is Brian Welch. I'm a VMware customer. I work at a healthcare facility out in California, and this is my first time doing a brown bag. A couple other interesting notes. First time doing a keynote presentation this evening, and first time showing off anything vSphere 6 to anybody other than myself. So what can go wrong there? Do a whole ton of demos this evening, so I'm hoping everything goes well with that, and I think it should. Anyway, as you mentioned, this is surrounding the vSphere 6 DCV certification. Couple of things that I figured I'd go over before that. The VCP6 is a little bit different than the VCP5. It looks like VMware is really getting more serious about the knowledge expected out of VCP candidates, and it looks like they've even thrown another test in there as well. This year I obtained VCAP 5, VCA, and VCD, and I was pretty surprised to see some of the things they're wanting me to know. They seem like they were almost VCA level items. So that being said, not much new. Not much new in the vSphere 6 networking compared to the 5.5 or even 5.0 for that matter. I've got just a marketing slide here where they talk about what's new in networking, and NIOC is the big thing. I believe they're making that feature available at any license level, which is nice. And then the multiple TCPIP stacks, which I won't be covering this evening, but it's a good one to know. That being said, the vSphere 6 beta exam, the topics are, again, like I say, very, very heavy. Looks like they're really wanting you to know a lot, even in the foundations. I think the foundations kind of rivals the VCP 5.5. Very tough. I was kind of surprised to flip through some of these things and look at the items they wanted you to know and be able to be tested on. And again, this is still in beta. I will mention I did take the VCP6 beta Delta exam, and it was very interesting to say the least. Certainly not like the VCP5 in any way, shape, or form. And without disclosing anything under NDA, I'll just say that it was a lot of memorization type tasks, which was unusual. I've heard a lot of varying things on that. Anyway, let's jump into the slides. So again, my name is Brian Welch. You can find me on Twitter at Brian Welch. I don't have a blog or anything like that to promote. I do have a blog, but every time I post something, it seems like somebody posts something way better. So I stick to posting items on Twitter, and then I'm also very active in a VCAP, VCD, and VCA group out on Google+. So if that's something that you're interested in, still very active, a lot of participation out there, very, very good resources. All right, well, we got to start somewhere, and I guess we'll start with VSS. So VSS is your standard switch. If you install ESXi, you're going to wind up with a VSS. And again, this is something, you get one VSS per host. by default on the first install, you get a management IP or a management port group. It's a software-based switch in the hypervisor, and it's defined in the VMware kernel. And what a VSS enables the hypervisor to do is manage traffic, whether that's virtual machine traffic, VM kernel traffic, or port group traffic. And we'll get into that a little bit later. I tried to keep the slide deck really light. I hope to do more demos, so anyway, we'll spend a little bit more time there. The basic adding networking to a vSwitch. When you go into your VSS switch, you're going to get a couple of options to add either a VM kernel network adapter, which, I mean, right on the description right there. VM kernel traffic handles things like vMotion, iSCSI, NFS, fiber channel, fault tolerance, vSAN, and host management. Virtual machine port group for a standard switch for VM traffic. That's where you define your different VLANs if that's something that you're doing in your shop. And then you've also got an option to add a network adapter. Again, very, very basic items. Not much to see there in the standard switch, and we'll jump into that a little bit more in the lab. So standard switches, these are something that you're going to be forced to use unless you have Enterprise Plus licensing. The VMware distributed switch is something, this is my one gripe. I wish VMware would change this in their licensing. Being Enterprise Plus is going to get you into the distributed switch unless you purchase vSAN licensing, which I think is an interesting move. Also, NSX customers, I believe, are going to be upgraded to distributed switch. Again, the vSwitches are maintained per host. So in my past experiences, in a previous life, I worked as a consultant. They were having massive VMware problems. 9 times out of 10, it was variations in the standard switch. Items weren't consistent. Port groups were missing. Traffic was it just horked up in a major way. So the standard switches, you really have to pay attention to consistency, making sure that if you add a port group on one standard switch, you're running across all of your other ESXi hosts and adding that into their standard switches as well. And in this little diagram, you can kind of see what a standard switch looks like. You have your physical adapters over here on this side, and then also your port groups. VM kernel adapters are used for VM host management traffic, vMotion network storage, fault tolerance, or vSAN traffic. That's kind of what we saw on the previous page there. If you need to expand your virtual switch, you certainly can add a port group by choosing one of these options up here to add a port group, and we'll definitely get into that in the demos. Multiple vSwitches per host. It's something that when you go to add networking, you can choose an option to break out an entire vSwitch. I know a lot of people that are very hot on adding a separate vSwitch just for management or just for IP-based storage, things like that. It's really up to you, not really necessary. I think it's just what people are into doing. I've been lucky enough to have enterprise licensing the past couple of places that I've been at, so not really something that I've made a practice of digging into and seeing what's going to be best for me. Also, the standard switch lacks a lot of the advanced features of the distributed switch, and I've certainly got a slide that'll show you what adds on top of that. The big value add for me is really the consistency. When you define port groups for a distributed switch, you do them once, and then when you add your host in, it just inherits whatever is defined into the distributed switch, which is a major, major, major thing for me. And also, I've got a link there. This link is absolutely fantastic. I mean, really, I could have probably just walked you through this whole document tonight because it pretty much goes step by step of what we're trying to do here this evening, but that's not very fun. It has pretty much everything in there that you'd like to know about a distributed switch or a standard switch and more. It's a very lengthy and detailed document. if you're interested in looking for something a little bit different than a standard VMware white paper and you want to get more information about VMware networking, I'd highly recommend Nick Marshall's book. Just a fantastic human touch. The way that he writes is something that it reads a lot softer than a white paper. It makes a lot of sense. So, VSS use cases and overview. If you don't have Enterprise Plus, well, then VSS, you're certainly the use case. Also, vSAN is that exception. But if you're not doing Enterprise Plus licensing, you're pretty much stuck with a VMware standard switch. It's not that bad if you've got a limited number of ESXi hosts in your environment. I mean, if you don't mind keeping track of your port groups and configurations on every single switch, on every single host, then it's really not that bad. But when you're dealing with clusters of, you know, I'd say 7 or more, it really gets to the point where you kind of forget about things sometimes. What a standard switch can do is forward LT frames, segment traffic into VLANs, use and understand 802.11q VLAN encapsulation, NIC teaming, and can traffic shape outbound only traffic. Again, very basic functionality out of the standard switch. And again, we kind of have a contrast on some of the advanced features that are available in the distributed switch. If you have no need for any of those, then a standard switch is probably going to work out for you. NSX, I will mention, is one that requires a distributed switch. vSAN, again, I'll hit on that, requires distributed switch. And if the Cisco Nexus 1000V is your thing for some reason, that is going to require a distributed switch as well.
Oh my gosh, you mentioned the 1000V. Oh no.
You want to talk about it?
Let's not. I've had some bad experiences with it, especially doing some upgrades. You know, always move your kernel port back to a vSwitch, and I think some people forget about that. So, yeah,
sure.
It can be interesting.
I mean, it had a time and a place. It added some functionality that just wasn't there in the distributed switch before. But I think the distributed switch has caught up to it, and I wouldn't wish one on my worst enemy. It just really makes, if you're doing things like upgrading your vSphere environment from one version to another, you have to bring that thing along with you, kicking and screaming, and it's painful. And anyway, I'm not going to talk about that because they'll never ask you a question about it.
So we have a question and we have a comment, and I actually wanted to kind of chime in on the comment because so vSAN does not require VDS, right? So Mike Wilson chimed in on that, so thanks, Mike. He also said Evo Rail uses VSS and uses vSAN. So there you have it.
Maybe I misread. I thought I saw something that if you had vSAN licenses, maybe you were entitled to VDS.
I never saw anything related to with vSAN that said it required VDS. It was just about the licensing that was separate for vSAN.
Okay.
So I never saw anything related to networking from that aspect. It was more related to disk types and things like that. But we can definitely check. The question though that we have is from Graham. Let's see. So you can script, switch, and port creations with Power CLI for consistency. So it's more of a, I guess, a statement than a question. I guess with the you can do that with the VSS, right? If you wanted to consist, but the problem with that is you have to maintain your scripts, right?
Absolutely, and I mean there's things that have come around like Ansible that have made that kind of configuration a little bit easier, but I don't know, the places that are using VSS, it seems like you start talking power CLI, and I don't know, but you're definitely right. That's something where you can bring some consistency to your hosts.
Yeah, it's kind of like what Graham stated. There's always a trade-off, right? You kind of have to weigh your options and see where the pros and cons lie in your environment.
Right, and I'm really hoping that VMware looks at the distributed switch and says, hey, this is something that it would be nice for it to trickle down into the more affordable licensing. But for right now, what can you do?
Yeah, that would be nice.
So here's our first set of objectives. Identify a vSphere standard switch and the capabilities, create and delete, add, configure, remove vNICs on a vSphere standard switch, configure vmkernel ports for network services, add, edit, remove port groups, and determine a use case. I'll just say I've listened to a lot of vBrownbags, and Graham he also always asks the best questions. So I'm pretty nervous that he's around on this one.
Don't be.
All right, let's get into the VDS. So again, enterprise only. If you don't have the licensing, unfortunately, it's not going to be available to you. One thing interesting about the VDS is it's a data center construct. So you define your distributed switch in the data center. You can add multiple clusters to one distributed switch, which is kind of a nice feature. Something that you can do. I wouldn't necessarily recommend it one way or another. One thing that I will mention, a lot of people kind of freak out about that being a data center construct. You can reboot your vCenter server and it's not going to take down your distributed switch. It's still defined in the VM kernel. So as long as your hosts are up and running, you're not going to have any switching problems or services that cease to function. Yeah, and again, it's simply defined in the VM kernel and managed in vSphere. So single point of administration for all of your ports across your hosts, which is very nice. Centralizes, standardizes, brings on a layer of consistency. And I guess I can strike this vSAN part here. There we go, totally accurate. NSX is still going to require it, and certainly 1000V. So the distributed switch capabilities. One thing right off the top that I always like to mention is LBT, or load-based teaming. LBT is really something I think that's kind of underutilized out there as far as what I'm seeing. I see a lot of IP hash load balancing, and we'll get into what those are later. But load-based teaming is a capability that will look at network loads on NICs and then will balance load traffic. So it's a true load balancing fault-tolerant algorithm, whereas things like IP hash are doing kind of funny things in the background to determine where to send traffic out. SRIOV. So if you want to pass through a physical NIC to a virtual machine, it enables you to do something like that. Enables NetFlow, which gives you pretty cool visibility into your distributed switch. NetFlow is an interesting one. You've got to turn it on in 2 different places. I'll show you that. Port mirroring, or span ports. This is something that you couldn't do in the past, and it's functionality that's come on in the past couple of versions of vSphere, which is really nice. If you're doing something like web filtering and it requires a span port, you can do that now. Not as refined as some of the things you can do at the switch level, but it's getting better and better. NIOC. This is one that VMware really likes to hit on very heavy in any certification test that they do. It's always in the blueprint. It's something they always want you to know about, and it's a little intimidating at first when you look at it, but hopefully I can speak to some things tonight that make it a little bit easier to understand. Ingress and egress traffic shaping in and out of the distributed switch. Don't really have much experience with that, but you're able to do that if you want. LACP on uplinks. Again, this is something that I've tried in the lab, and I've had decent results in it, but really I would just prefer to use LBP. Keep it really simple. Don't need to do any switch configuration on that other side, where LACP you absolutely you need to have a port group on the other side that's 802.3AD compliant. Link aggregation control protocol. And VLAN, again, this is another one that is, I think there's certain use cases for it. It's one of those things that VMware absolutely wants you to know about. The ability to create a VLAN, which is essentially a container or promiscuous VLAN that can have sub VLANs underneath it. And I'll go through that, show you how to configure it, and then give some examples of why you'd want to do something like that.
So one thing that that I think is kind of not mentioned a lot for the VDS is the health check. I don't know if you use that, but I've used it in the past, and I think it can come in handy.
Certainly, and in fact, I always turn on health check in the VDS. And so when I was preparing for all of this in my lab last night, health check was blowing up my distributed switch. I had changed it into you, and health check was just angry with me. So in order to clear all the errors that my host was throwing, I had to turn off health check to get past all the red. But it's certainly a nice way to view the health of the distributed switch, and we'll touch on that as well. But you're certainly right on that. Yeah,
so as soon as I said that, we've had some people chime in. So Graham says health check is great for not shooting yourself in the foot. I totally agree. It's a great way to see if there's any discrepancies between your VDS and your physical switch. Let's see, prepare the health checks to show MAC flapping on Cisco switches. That's Larry. Private VLAN requires a physical switch that supports it as well. That's a good point, Mike.
Absolutely. Mm-hmm.
Yeah, so LACP, the network guys understand. Load teaming, not so much. That's another comment also from Graham. And Larry chimed in again. It hashes all the MACs across uplinks as one MAC address. So, oh yeah, and go ahead, I'm sorry.
No, go right ahead.
Oh no, Graham chimed in with another feature that most don't either think about or use, but you can also back up and restore your VDS, right?
Right, and that's highly recommended. When I was having the issues last night, that was the first thing that I was kicking myself about. But this is kind of a burner lab. I set up quick, short, and sweet just to show the capabilities of this, and I wasn't too worried about it. But in an enterprise environment, certainly you want to back up that config and have that. Okay, objectives for the distributed switch. I could run through those, but we see them right there. I've copied these off to a little text document. So when we go through in the lab, I'll just kind of mark them off that we've been through these. But a lot of this information kind of is very similar in the standard switch, with the exception of some of these very specific items right here. Migrate virtual adapters to and from a standard switch, migrate virtual machines to a distributed switch. I mean, we'll take a host and move it into the distributed switch, and I've got a continuous ping going on a host that's sitting on a standard switch, and we'll move it in and see what that looks like. And then also take a look at some of the LACP things. Of course, I don't have a switch on the other side to configure that port channel, but we'll just assume that some network guy on the other side did that for us, and we'll go on right through the demo. And here's some of the features in the 2.3, which get a little bit more specific. VSS, VDS policies, security policies and settings, port group blocking policies, load balancing and failover, getting into a lot of the stuff like LBT, IP hash, so on and so forth. VLAN, PVLAN settings, traffic shaping, TCP segmentation offload support for a virtual machine. I'm not quite sure why they put this in there. I'm sure some people can chime in about it. I know if your NIC supports it, the hypervisor just turns it right on. If your operating system supports it from there, there's some things you can do to turn it on or off. I think in Windows LAN, they want you to do some registry settings. In Linux, they want you to edit a couple of files to turn it off. But I'm not sure why they want to put that in there, because really if it works, it's going to be on. Jumbo frame support. This is one that's really difficult. Jumbo frames need to be turned on end to end, or else you're going to see massive problems. So, I mean, from a server network card all the way up to the servers that it connects to, into your distributed switch and your port groups, you've got to have jumbo frames enabled end to end, or you're going to see some very, very unusual networking issues. And determine appropriate VLAN configuration for vSphere implementation. Got a couple resources here. I mean, all standard VMware documents. The VMware documentation on networking is outstanding. It is very thorough. A lot of great information in there, and pretty easy to read. I don't think that the white papers are as boring and plain as they used to be. Maybe I'm just getting nerdier, but it reads pretty well. A lot of good information in there. And like I say, there's not much change from vSphere 5.5 to 6 as far as networking is concerned. It's just really the propagation of NIOC down into other licensing levels. And with that, let's jump into some demos.
Should I be worried that your demo time screen has a purple screen?
Well, that was from 4.1. We're demoing the 6 stuff, so we should be good, right?
Okay.
I tried to find a vSphere 6 purple screen. I just couldn't do it. Maybe somebody can send me one.
Is that your way of like maybe tricking Murphy?
Yeah. Well, I don't think tricking Murphy works, but fingers crossed. So here's my lab. I mean, it's a very small. I'm running this thing all on a Mac Mini. One virtual machine just for the purpose of the demo. If you guys need a really small virtual machine, TTY Linux is outstanding. There's an OVA floating around out there on the internet. It's something like 25 megs. Essentially, all it does is boot up into a shell. It obtains an IP address, and you're able to ping it. I'm running a very light system here. It's an older Mac Mini with 16 gigs of RAM, so I'm really squeezing as much as I can into there. Ahmad, I've got, just for you, I've got a Windows vCenter host in my lab.
Oh,
no VCSA.
I'm sorry. We can't talk anymore.
So it's just for the purpose of the lab. I run other services like DHCP, DNS, Active Directory. I'm really frugal. I live out in Fresno, California. It gets up to 100 degrees in the summer. If I run a big box in my house, our air conditioner works overtime. So.
Oh, that's kind of why I stuck with shuttle boxes and a Mac Mini, but that's a different story.
Yeah, sure. I've got a great lab at work, but I figured for the purpose of this, I didn't want to try to jinx it going through some VPNs and all that other stuff. So we'll just start right from the top. You'll notice that I'm not going to use the C# client for anything, and the reason being, a lot of the new networking stuff just will not show up. LACP is one right off the bat. If you try to go in and find the LACP stuff in the FAT client, it's gonna take you forever to find it because it's just not visible. And the other day, somebody was asking me about the traffic shaping settings on a distributed switch, and I was looking in the FAT client, couldn't find it, and I was just banging my head on the desk. And anyway, that's how it goes. All of the feature sets are going to be in the web client, and the web client in 6 really is better. I mean, I've got a dog of a lab here, and it snaps around pretty quick. So let's start with the standard switch. That's my distributed guy. So anything you want to do is going to be under the networking tab. I think the web client has done a really nice job of kind of cleaning and tidying this up. I actually like the look of the web client for the networking a little bit better than the C# client, but I know everybody's mileage kind of varies. I work with some pretty advanced VMware administrators at my work, and they won't even open the web client. So it's kind of a preference thing, but eventually that preference is, and I think that time has passed, it's certainly shifted towards the preference of the web client just because of functionality. So in here, we can just cycle through some of the options here. vmkernel adapters, this is just a stock standard switch. This management network adapter is something that comes in by default when you're installing ESXi. I mean, when you run through the install, you either obtain or set an IP address, it's going to create this, this vmkernel port group for you. Physical adapters, this will show what you have connected to your ESXi host. Running nested, so these are all virtual. TCPIP stacks. I had mentioned before that there's the ability in vSphere 6 to use separate TCPIP stacks. This is where you define those. Again, it's something that is not on the outline for the VCP6 Foundation, so we're not going to cover it, but I figured I'd mention that this is where it's located. This section is completely new. And then also IPv6 support is something that's new. I've read that VMware does not recommend flipping on IP version 6, that they tend to reserve IP version 6 for greenfield deployments. And I can't speak to its functionality, but I have it enabled for the purposes of this just because I figured I'd turn everything on in the lab. So back to this is kind of the main screen where you come in here and modify your virtual switch. If we want to add host networking, this is kind of the first slide that I had. vmkernel adapter, I like to think vmkernel is just the services that the hypervisor offers. Port group for virtual machines, I like to just think of those as the VLANs that you want to configure. Also, if you have some other networking services where, let's say you need to do a span port or also have a promiscuous port group for sniffing traffic, something like that, I like to add in a separate port group here. And then adding physical network adapter. Again, all very basic, simple things. I'm sure this is something that everybody's done before, and I'm really just doing some review at this point. Let's go ahead and add a port group. Next, select an existing standard switch. It's got my default standard switch in there, or I could create a new one. So if I really wanted to get granular and have multiple vSwitches for multiple different types of vmkernel services, or for some reason VLANs, you could do that here. Choose a network label. You've got a couple different options for VLAN ID. 555 I defined in a previous just for a test. If you choose all, any VLANs are going to be able to be, depending on your network trunks coming in, if you choose all of those will be defined, and you can choose to tag the VLAN at the virtual machine level. But if you choose a very specific VLAN like 101 here, it's just going to allow you to talk on VLAN 101, assuming that you've got that trunked in on your connectivity to physical switching on the other side. And that's it. So again, making an assumption that this physical adapter, whatever it's connected to on the other side, I'm passing VLAN 101 through. I'll be able to create a virtual machine and add it on to the port group for VLAN 101, and everybody's happy.
All right, so are people happy using VDS for all switches? This is coming from Graham, by the way. Must admit, I still use the standard VSS switch with a pair of 1 gig uplinks for management. So, Brian, you want to chime in, or?
I mean, really, I don't know if there's a right answer for that. Again, like I say, I've been at places where I've been lucky enough to have Enterprise Plus licensing, and I haven't had to vet out a really elaborate standard switch deployment. But I've certainly seen in other shops that I've been to where people certainly break out a separate VSS with a very specific NIC tied to it for management. And I mean, it's definitely a great way to separate that traffic. I mean, you are physically separating that off from not only from the adapter connected to the switch, but all the way up into your standard switch at the ESXi host. So there's certainly nothing wrong with that. Really, it's just preference. I mean, what's going to work for you? And I certainly see a lot of it, but it's something that I don't really do. But I can't say that one way is more right than the other.
So I think part of it is just old school mentality, right? When we were doing VMware way back in the day, I mean, that was kind of the thing, right? You kind of broke up everything on your VSS. But today I really don't see a reason why, unless you're using, the 1000B, why you would really want, and of course licensing plays a role in that as well, right? So
sure, and
otherwise,
and really 10 gig is what's really busted that all up for me, because with the advent, or let's just take, I'll just use Cisco UCS as an example. I mean, for me to get a 1 gig network adapter, I have to go through and provision it in the UCS level. And really, it's still writing through that same VIC that's in the blade anyway. So really, it's kind of a logical separation, and then you're logically separating it again. And I don't know, with 10 gig, it's really consolidated a lot of those connection types, and you're not really dealing with, I don't know, 8 1 gig ports on the back per ESXi host. But yeah, I think you're right. There's still a lot of, that's the way it was done in the past, and it's still being done now. And I don't think there's a wrong and a right. And it's certainly not within the scope of this exam. I don't think they're going to ask you what is the best thing to do with your standard switch for management traffic. So it's something that I've seen. It's something that I understand. Okay. Migrate a vmkernel network adapter to the selected switch. So it's going to kind of be grayed out. I've never seen anybody move. In the case, I think, like Graham was saying, if I had 2 standard switches here, I could migrate a vmkernel adapter up from one switch into the other. And it works very similar to what we're going to do migrating migrating a standard switch into a distributed switch later on. So I'm not going to demo this one, but just know that that is what this button is for. And the web client is very, very good about doing pre-checks. You can see analyze impact. If you're doing something really stupid, it's going to let you know. It's going to tell you that this is going to fail, and you're not going to do things like drop out your management network underneath you so you can't get to the host anymore, which is very nice. I've done that more times than I'd like to admit. I've got to go into the DCUI and reset the management networking, and that's never fun when your data center is not close to you. Virtual switch settings, right off the bat, MTU. If you're doing jumbo frames, that's where you're going to want to change that right there. When I was having issues last night, I changed the MTU on my distributed switch, freaked some hosts out, and I was worrying I was going to have to rebuild my lab before today. Security. So these are interesting ones. Promiscuous MAC address changes and forged transmits. By default, all of these are set to, I'd gone through and changed them. By default, all of these are set to reject. By changing these to accept, what's going to happen with forged transmits is virtual machines are going to be able to send frames with a MAC address that is different from the one specified in the VMX. I'd have to turn to the people out there for a use case for forged transmits. I've heard some people talk about using it for clustering. If you've got a virtual IP that you need to share a MAC address pass between virtual machines, I think that that's something that you allow on the vSwitch or the port group, and you're able to get away with things like that. And also MAC address changes. I think that goes along the same route. I'm interested to see what other use cases people have out there. And then promiscuous mode. That allows the adapters connected to that DV port group or to the vSwitch to see all frames passed on the switch. If there is multiple VLANs defined, if you're choosing that option for 0 to 4094, you'll be able to see traffic on any VLAN. If there is a very specific VLAN defined, you'll only be able to see all the traffic on that specific VLAN. So things like wire sniffers, I think it's very common for people to turn on promiscuous mode and then sniff traffic on what's going on the VLAN or the entire switch.
So both Mike and Graham are chiming in. They both at the same time came up with a network load balancing. And then, yep. And then Graham chimed in and said promiscuous mode for Wireshark.
Yeah, certainly. It's another thing that's interesting that I'll point out is, you know, there's only 2 new features that VMware is really touting for the distributed switch, and I think there's a very specific purpose for that, and it's NSX, and all of the really advanced functionality is coming in there. I think they're kind of leaving a lot of that special sauce out of the distributed switch and trying to get people to move over to that. I've yet to see NSX in deployment in healthcare especially, but I'm really looking forward to it. I'm excited to see what it can do. There's a lot of exciting things, load balancing in the hypervisor level that look very, very fun. A lot of the microsegmentation stuff is, I can see some benefit, but it's not as exciting to me as some of the services, layer 2 bridging that you can do, so on and so forth. So I think they're keeping the DVS feature set pretty low on purpose. And these things have been around forever, the promiscuous MAC address changes and forged transmits.
So Mike chimed in as far as the new features on the VDX are more towards network I/O control, right? V3.
Absolutely, yeah. So again, that's a feature that VMware really loves, and I'll jump into that here shortly. it's something that I can tell you in a lot of their blueprints for a lot of their other tests, NIOC is always something that they talk about. I mean, they want you to know it inside and out, especially for some of the VCAP things. So it's something I think they really want you to know about that feature. I haven't had a use case for it yet with a lot of the 10 gig links that we have. I mean, we see such minimal saturation on those that I just haven't had a use to turn it on yet, but I'm excited for the day that I will be able to turn it on and see it doing something. Perhaps that's something more with the people that are dealing with the 1 gig copper links that are seeing those kind of contentions when a vMotion fires off and a link is saturated. Just take a look here just to sanity check the SS stuff. Create, delete a standard switch. Add, configure, remove VNIX on standard switch, vmkernel ports. And then, of course, the VNIC part, I mean, just to go through this really quick. I've got this virtual machine connected to my distributed switch, but if you want to change your port groups on what you're connected to on the standard switch, you do it at the virtual machine level. Let's jump into distributed switch. And the first thing I figured I'd go over is the network I/O control. I mean, it's really I can't stress enough how tested this feature set is, and I think the version 2 was a little bit more complicated than this. This is a little bit cleaner and easier to follow and understand. Two different major things to think about with network I/O control are shares and reservations. The shares have a value. You can see there everything is set to 50. There's 100 there. If your share's normal, 50 is the standard value for that. 100 is high, and then also there's a 25, which is low. One thing that's important to remember about the shares, it's under contention only. Network I/O control is not going to be running all of the time, hard limiting or prioritizing your network traffic if there's no contention. It's really important to remember that if there's contention, that's where shares kick in. The difference are reservations and limits. A limit is hard. If you set a limit of 1 meg for management, you're never going to get more than 1 meg. It is a hard limit regardless of contention. And then reservation is kind of the other way around. If you're reserving, I don't know, 1 gig for FT traffic, you're always going to have that available, contention or not. So those are just things to keep in mind. The resource allocation is defined at the distributed switch right here, and it's just based on your traffic type. So it's pretty simple, pretty easy to configure once you understand the difference between shares, what the share values are, reservations, and limits. These are just the stock default settings. I haven't gone in here and modified any network I/O control. So this is what you can expect to see on any deployment if you have it enabled in your vSwitch. And we'll take it from the top. So this is, of course, where you enable it in NIOC. Most of the main configuration settings are done at the root of the DV switch. So if we jump into edit here, name, number of uplinks, number of ports, network I/O control enabled or disabled, and a description. All pretty simple stuff. Under advanced, we've got our NTU, multicast filtering mode, basic or IGMP, MLD snooping. Discovery protocol. This is pretty cool. I think it's kind of an underutilized feature as well. you have the ability to work in vCenter and then also go around and touch the switches that it connects to. It is very, very useful. I'm sure everybody knows what CDP is, has used it at some point in time or not. Show CDP neighbor will show devices connected to a switch. So this V switch will actually broadcast CD packets back to the switch saying, hey, I'm a switch. There's some pretty cool information to be seen. LLDP is just the industry standard of that. A lot of HP switching leverages LLDP, and pretty much any switching other than Cisco uses LLDP. So that's where you turn that on right there. I think it should be worth noting that this is an Enterprise Plus. You might be wrong on that, but for some reason I thought it was Enterprise Plus only.
So it's funny, a couple things to note. So the VSS only has CDP for the discovery protocol type, and that's coming from Mike.
Oh yeah, yeah, absolutely.
And Larry chimed in and said all new Cisco ACI will be using LLDP and not CDP.
Interesting. So they're doing that in the 9K. It's a modular feature that you have to flip on.
Larry says yes.
All right. Well, that's good to know. Cisco likes to. Well, I won't go down that route.
let's keep this family friendly.
Oh boy.
Or vendor friendly, as we would say.
Sure. I love Cisco. All right. Oh, again, I think we wore this out. Administrator contact, of course, it's going to tweet me when there's problems.
Yeah, because that's what I need is my switch sending me a tweet, right?
Yeah, exactly. So here's my uplinks. The thing I love about VMware is they always do a great job about putting a pretty picture there and telling you exactly what it is. They've done this since the beginning of time, and I never get sick of it. Maybe it's just me, but I really appreciate it. So this is kind of the uplink policies. You can see here, security. We've got our promiscuous MAC address changes towards transmits. Ingress and egress traffic shaping, I've got that disabled, but if I had it enabled, these are the options here. And I can always go and edit this. Blocking ports. This is one thing that was a major feature of the 1000V. They would say, hey, you can SSH into the switch and you can shut down a port just like you would any other networking port. And it's something that has come in, I think at version 5, they allowed you to actually block a port. If you have this allowed, you can go through in your distributed switch, take a port and shut it down. I'll be honest, I'm not quite sure what vendor configuration is. NetFlow. This is, you've got an opportunity to turn it on here. You also have to turn it on in the distributed switch as well. And that goes for all of the port groups as well as the uplinks. So if you want to see NetFlow information come through to your receiver, you got to make sure that not only is it set up in this section, but also in your port group as well. And let's see here. There we go. So if I didn't have, I've got this set to disabled, I'd never be able to see NetFlow information in my receiver for my management port group. Security, here's where we modify the settings, very similar to a standard switch. Again, a lot of this stuff carries over. Your port groups are going to look almost identical between a distributed switch and a standard switch, but then you've got your extra special stuff, traffic shaping, ingress and egress. It's worth noting that you can apply it individually to each port in the port group now as of vSphere 6, which is something used to be entire port group setting. Now you can just apply it to individual ports, which is nice. VLAN type, let's jump into this really quick. The concept of private VLAN, and it was mentioned by somebody that your switch has to support it on the other side as well. Basically what a private VLAN allows you to do is create a promiscuous VLAN. And what that means is it's a VLAN that can contain other VLANs. And I've got a configuration here I'd like to show really quick. I was worried that I was going to get all of this done in 15 or 20 minutes, and now it looks like we've got about 4 minutes left. So.
Take your time. We're in no hurry.
That's great. So, private VLAN ID, I've gone through and created a couple already. I've got a promiscuous, a community, and an isolated. So promiscuous is like a container VLAN. And then underneath that container VLAN, you can run separate VLANs that can only run in the private VLAN. So I've got a community and an isolated. What this means are this. Promiscuous, the VMs are reachable and can reach any machine in the same private VLAN. So I could create 15 virtual machines, assign them to this promiscuous VLAN, they can all talk to each other. No problem, no restricted. Isolated. If you create a VM and you put it in that isolated private VLAN, what's going to happen is it's only going to be able to talk to the promiscuous VLAN and nothing else. Another example is if you have two isolated virtual machines, they're not going to be able to talk back and forth to each other. They're only going to be able to talk to that promiscuous. So it's almost like I don't know, I wish I had a drawing tablet here. You've got your main promiscuous guy here, and you've got an isolated VM down here. You can see those circles, right? That isolated VLAN can only speak up to the promiscuous, and it couldn't speak up to another isolated virtual machine on that same 502 VLAN. I've heard of people doing some use cases for this where they're in a classroom or something like that. You know what, before I get into that, I'll talk about community. A community VM can talk to each other and the VMs in the promiscuous VLAN. So we've got our parent VLAN that's 500, promiscuous. You've got multiple virtual machines here. Those virtual machines can talk to each other. They can talk to promiscuous, no problem. Isolated, it can only talk to the promiscuous VLAN. The use cases that I've heard, I came from education, and we would set up private VLANs and community VLANs, student virtual machine desktops. They'd be able to talk to each other, or if there were problems where teachers did not want the virtual machines to talk to each other, we'd make them isolated. So they'd be able to talk to promiscuous, which could be a device like, I don't know, a virtual router, something like that, to just kind of isolate or seize communication from VLANs between each other. I'm sure there's probably some awesome use cases for it, but again, it's one of those features that I don't hardly use, but VMware wants you to know all about it.
So,
does anybody out there have any cool examples of?
I was going to chime in, but the community said the same thing. I was going to say DMZ is definitely a great place. So Dan and Graham both jumped on and said the same thing, DMZ. So that's
Right.
typically where I've seen it. I've worked for 2 banks, and I've also seen it for segmenting maybe some different zones to isolate communication is another use case.
Yeah, that's awesome. That's good to know. I can certainly see how it would be leveraged. Again, I'm just a lowly customer out in Fresno, California, so it's good to hear of other examples of how people are taking advantage of that. Let's see here. So time check, I've got 6:30. I think I've got a couple more things to go through. I can certainly keep going here. VDS create. Oh, you know what? Let's do the migrate because that's a big one. Another thing I kind of like about the distributed switch, things you have turned on, I've got network IO control, gives you a cool little icon there. Health check enabled, you can see that's right there. All right, so here's my guy. I want to get him into my distributed switch. So add and manage hosts. Going to choose the option to add a host. Here's my guy, he's only running a standard switch. Select adapter task. This is really cool because it gives you the option to really define what you're going to do with your standard switch ports. Are you going to map those over to distributed switch port groups? You get all your options right here. The first option is it's going to take your physical adapters connected to the ESX host and move those into the distributed switch, and we'll kind of go through and see what the standard switch looks like after we do this here. Manage vmkernel adapters, it's either going to add or migrate the network adapters to distributed switch or assign them to port groups. Really kind of cool way it's just lines everything up. You got your standard switch. When you move it in, it gives you an opportunity to map everything coming in so everything goes to the right place. Migrate virtual machine networking. So I've got a VM running on a port group that's on my standard switch, and I want to bring that virtual machine over into the distributed port group. If you check that, your virtual machine is going to come into your distributed switch, and there will be a minor, if any, interruption. I think usually it might drop a ping or two, but for the most part, it's a pretty seamless operation. So that part where I showed you earlier, you change your virtual machine settings, what port group you want to connect it to, it automatically does that during the migration. So manage physical adapters. This is essentially just defining what's going to happen to the physical adapters on the way into the distributed switch. I've got 4 adapters in here. Only one is in use by vSwitch 0. And I got to do something with this here. Demo hell. There we go. So
I was going to say you spoke too soon, huh?
yeah, exactly. So auto assign, it's just going to choose the best uplink port group to put it in, which is the only one I happen to have right now. And I'm just going to go through and this gives you a summary of exactly what's going to happen. It's going to take this VNIC, which happens to have my management for my vSwitch for the host I'm bringing in, and it's going to migrate that into the distributed switch. This is the mapping of the kernel adapters, vmkernel 0 management network. I don't need to migrate because I've already got that functionality on the distributed switch. If I wanted to assign it to a port group, I could certainly choose any one of these here. Analyze impact. This part is great. Hasn't been around in previous versions. I really like seeing what's going to happen here. It kind of reduces any chance of disruption, hopefully, to your environment. VM networking. Oh boy, looks like my VM was on the other host, but at this point in time, this would allow me to pick the port group that it's on, the source destination, and make sure that you don't have any VLAN discrepancies as you move from one port group to another. Ready to complete. And got my tasks hidden. So let's take a look at this guy here. LACP on the uplink port group. Let's take a look at that really quick. This is something that's done on the uplinks, not the distributed switch. It's your physical connections from your host to your switch. Assuming that you've got it configured on the other side, you come into this guy. I'm trying to speed through a little too much. Hold on one second. It actually is, no. All right, guys, where's it at? Anybody out there have any recommendations about where the LACP is? I'm having a momentary lapse. There we go. Migrating network traffic to lags. I don't have any lags defined. I'd have to add one in here. Lag 1, number of ports. All depends on what's going to be on the other side. The mode, active or passive. Again, that really depends on your switching. And then your load balancing mode. This is something that you're going to want to ensure that you sync up with your network guy to make sure this matches on both sides. When you create a lag, that's just one part of it. Then you move uplinks into the lag, and that's how you get your uplinks set to the LACP load balancing mode. I'll kind of jump through a couple of things here as far as failover. Done on the port group level. If you look at teaming and failover, that's where you can decide. Your default is with the distributed switch is going to be originating virtual port. If you've got Enterprise Plus licensing, route based on physical net load is certainly one that I really, really like. IP hash is out there, and it's widely deployed. Mainly for Ether channel, Cisco type connectivity. Route based on source MAC hash, just another algorithm to figure out which uplink to send traffic down. You can see here, right now I've currently only got one active uplink in this port group. For any of those to make any kind of a difference, with the exception of explicit failover, you've got to move these adapters up and down. Again, really up to you. Different people choose different things for different reasons. I really like route based on originating virtual port. If you're using explicit failover order, this is something that there's going to be absolutely no load balancing at all. You've got active, standby, and unused uplinks. Explicit failover, if uplink 1 fails, it's going to go to 2, and it's not going to automatically fail back. If you have this to no, if you have it to yes, when uplink 1 becomes available, traffic will shift back in there. But again, no true load balancing. Again, there's net flow, traffic filtering and marking.
So I have to ask, and this is kind of off topic, but the dog in the background.
Oh, I'm sorry. Can you hear that?
No, it's cool. I just didn't know if you realized that the dog was barking and.
Yeah, so I've got a high maintenance Australian cattle dog, and she's excited about something outside right now. I've been trying to tell my wife to keep her quiet, and
Oh, I didn't know if you had her like outside the door and it's trying to get in.
Yeah, she's on the other side of the window. I think the neighbors are. I don't know. There's something going on there.
No worries. I just wanted to give you a little bit of help for that.
Yeah, well, I appreciate it. So I know that we're running pretty long, but I feel like I've gotten through the majority of it. I know I got kind of scatterbrained and unfocused there towards the end, but are there any questions, anything anybody else wants to see in particular that I could walk through, or?
So I don't see any questions here or Twitter. Anybody have any questions or comments they want to chime in on? So do you want to, maybe before you call it quits, do you want to kind of give any feedback or advice on the exam?
Sure. I could certainly speak to that. Well, right now it's beta and it's $50, so it's a great way to kick the tires. If you're a current VCP, you qualify to take it. I think if you're not a current VCP, you won't even see the option to sign up for it. But it hasn't gone GA yet. I've heard varying things from varying people. I heard previous presenters say there was a lot of challenging. If you had this situation, what would you do? My mileage greatly varied. I had a lot of memorization tasks, like, I mean, without jumping in the NDA, it's hard to give some examples, but they would ask a question about doing something, and then you had 4 options, and the answers were all very, very similar, just maybe with different punctuation. And it was very detailed and bizarre. But there was a lot of there was nothing about vVols that I saw in the exam. As far as networking is concerned, a lot of that stuff is identical. So anytime a networking question came up on the exam, those were typically a slam dunk. I'm not sure if I should have said that about the vVols or not, but I know that that's something that a lot of people focus on. It was 95 questions. I think I finished it with about 40 minutes to spare, and I'm not quite sure how I felt about it when I left. If you take a beta exam, you don't get a result. It just pretty much spits out a paper that says, thanks for playing. We appreciate your $50. When the test goes GA, we'll let you know. So I'm going to be sure to put something on Twitter one way or another how it went, but I figured it was if anything, a great way to kick the tires and see what VMware's thinking on the next exam. So I think when it does go GA, hopefully they sort out some of the weird questions and they've got a pretty solid exam. But I will say this, the blueprint requirement is tough. I mean, some of the items that they have in there, I thought, man, I'm gonna have to get into some white papers and look up exactly what this means. I think they're trying to bring more value to the VCP, and it certainly looks like by having these kind of items, they're going to do that.
So Mike chimed in and said the delta was supposed to be 70 questions.
Oh, I'm sorry. Yeah, just the straight exam is 90 or 95. The delta was shorter. And I believe the delta tried to focus on things that were new, but I'm not sure that I'm not sure that it did exactly. I think they've got a pool of test questions, and they're looking to kind of whittle that down to more pertinent, or perhaps just throw out questions where everybody bombed and stick to some bell curve type. Hey, the majority of people got this right. Who knows what goes on in their testing land? And I know that they've completely shaken it up over there, so it's going to be hard to say what it's going to look like going forward.
And I guess if you have a VCAP, if you wait and I guess take the VCIX, I think you automatically get the VCP6 along with the upgraded.
You do, yeah, exactly. And VCIX is something I'm really looking forward to. I mean, just looking at the Foundations beta and then the VCP DCV, it's tough. So I'm guessing with the VCIX, they're going to make it really tough. Kind of off topic, but when I took my VCAP DCA, when I left the testing center, I felt tired. I mean, it was such a long. I don't think this is violating NDA at all, but it was 25 questions, and each question was more of a scenario where you had to accomplish something. So it might have been one step, or it might have been 15 steps. So I mean, the first question that I did, I remember looking at the clock thinking, oh man, I just spent 25 minutes on that. And so when you've got that time crunch and you're trying to do that stuff, and then time is constantly a factor the whole time. I think the VCIX this time around is going to be much more difficult, and that is certainly a fun exam. If people are thinking about taking it, it is outstanding. It's all task based. You log into a live environment, and you've got to know what exactly to do. There's no faking it on that one.
Yeah, VCAPs are either you know it or you don't know it type exams. So I'm definitely looking forward for the VCIX. Just haven't decided which one I will take, since if you have both VCAPs, you can take one and automatically be upgraded to VCIX, or
Right.
you have to take both to be considered VCIX certified. So we'll see.
Sure. Yeah, I think I'm going the DCA route. I did the DCD last, and it was that's a very hard exam as well, and totally different. I need business objectives and constraints, requirements, all that fun stuff.
Yep, I just took it a week ago and passed, so I'm right there with you.
I saw that. Congratulations.
Thanks, appreciate it. So, yeah.
Well, hey, I just want to say, everyone, thanks for sticking with me. I was wildly nervous this whole time, and thanks for sticking with me and listening to me ramble on, and hopefully there were some takeaways from this evening.
No, this was good good info, and you did awesome. You rocked it like a pro, and the demos, especially the demo gods, were in your favor tonight. So awesome job.
All right. Well, hey, I really appreciate it. It was fun.
Yep. And with that, I'm going to stop the recording.